Welcome to another tutorial of ANSYS 2018. In this video, we are going to see that how we analyze a cantilevered beam in ANSYS APDL. This is our beam. It is basically a rectangular beam whose width is 1 meter and whose depth is 2 meters. The modulus of elasticity value we will be using will be 1000, and the p value is a unit load acting in the upward direction, and the length is 5 meter, and this beam is fixed at the node 3 and a point load is acting in the vertical direction at the node 1. So how we will gonna analyze this beam in the ANSYS APDL, and how we will find the displacements, the rotations, the display and all the moments, the flux, bending stresses, we will gonna see in this video for a cantilever beam. So I am opening my ANSYS APDL. So first of all, you would have to save your file, and after that, after saving the file, the first thing you have to do is to select your analysis type. I will be doing the structure analysis, and after that I will be simply going to the preprocessor. Now in the preprocessor, first of all, you would have to select that whatever element you will be drawing, what will be its type. So I will be going to add, and here I will be clicking on add. Here I will be going to the beam. Now in case of beam, we have 2 node 188 element and 3 node 189 element. I will be going with the 188 element. Why? Because 2 node 188 element is used for the straight elements, or where we can connect a beam an element with 2 nodes, while 3 nodes 189 is basically used for curved elements, like you can say the analysis we do in case of arches. In case of arches, we have a one starting node, one mid node and one ending node, so we have 3 nodes. But in case of simple straight beams, we have 2 nodes, one is the starting and one is the ending node. So I will simply selecting this and I will be applying this. After defining my element type, now I will be going to the sections, and in the section I will be going to the beams and in the common sections. Now as I have said that we have a rectangular beam, so selecting the rectangular type here, and its width is 1 meter, so I will be writing B as 1, and its depth is 2 meter, so I will be clicking on this and simply selecting this my as a section of the beam. So when I have defined the section, it will automatically calculate its area, it will automatically calculate its moment of inertia according to the section dimensions. Okay, so my section has been selected. Now I will be going to the material models, and here in the material models I will be going to structure linear elastic, and I will be simply defining its modulus of elasticity value E, which I just considered 1000. For the Poisson's ratio, I would write it, but it will be not used in case of beam analysis, and I will simply click on OK, and now my material model is defined. I will simply close this. After that, I will be simply going to the modeling. In the modeling, I will be drawing with the help of key points. So what I will be doing, I will be drawing key points in active coordinate system. I will be drawing 2 key points. So first will be at the origin, all elements will be 0. Okay, so this is my first key point. Now if you see here, I told you that my length is 5 meters. So from this origin to this, I will be having the total length of 10 meters. In x direction, no change in z or y direction. So what I will be doing, I will be simply, I have already drawn the first node. Now I will be simply going to the second. I will simply draw the second key point, and in the second key point I will be simply changing the x value to 10, and I will be click on apply. Now my key points have been drawn. Now I will be doing draw a straight line between the key points, so this here. So my key point are now connected by a straight line. Okay, and now what I will be doing, I will be meshing it so that I could divide it into the 2 parts. So for the meshing, I will be first of all going to the size controls. In the size control, I will be going to do the manual size. In the manual size, I will be going to the lines, and here I will be click on the picked lines and select the line and apply. And here number of element divisions. So what we have seen is that our beam has one center node, so I will be dividing it into 2 parts. So totally I will be having 3 nodes. Okay, 1 2 3. Okay, so we have the 3 nodes. Now I will be simply going to the mesh tool, and the mesh tool I have selected, and I will simply click on mesh, simply select this and apply. So if you see now, I will plot the nodes. So I have 3 nodes, 1, 2, 3, from 0 to 5, 5 to 10. So after the meshing, what I will be doing, I will be applying the loads. I would be applying the loads on the node, this node, origin node, and here I will be using a structural force, and on the nodes I will be selecting this node and apply. So what I will be applying, I am applying a unit force in the y direction. So I was selecting this and click on OK. So my unit force is applied in the vertical direction. Now one more thing is that our this node is fixed. So I will be going to this and click on nodes. OK. All degrees of freedom, this will be equal to 0. And now this node is fixed, and at this node a vertical point load is applied. So after doing all this, then I will be going to the solution options, and I will be simply click on the solve and current load step options. So I will simply click on OK. So you can see that it has shown the message that the solution is done. Now after the solution, we will be going towards how we measure the vertical displacements or all these things. So one thing, I would be plotting here the deformed shape as well. So you can see okay, so you can see that in this way we have applied the load in the upper direction. So its shape should be like this. Here, since it is fixed, so it is not having any displacement here, but here I have applied a point load, so it has displaced. So in order to get the more results, I will go into the list results, and here in the nodal solution, if I talk about the displacements, so if I apply this component of displacement, so I am having 0 displacement in the x direction. Why? Because I have applied the force in the vertical direction. So when I am applying the force in the vertical direction, I am having some displacement at the node 1 on which I have applied the force. So this second node was our fixed node, and at the third node this was our displacement. So a maximum displacement value is occurring at the node 1 on which we have applied the load. Also we can check something else. We can also go with the rotation as well, and that what is the rotation acting on the y direction. So you can see that we do not have any rotation at any node in the y direction, but if I click on z axis, it is showing some rotation. So we are having the rotation not in the direction of the displacement, we are having the rotation in the z direction, and the maximum rotation we are having at the node point 1, which is minus 0.3. So that was all about the analysis of a simply supported of a cantilever beam. One more thing is that how we determine the moments as well. So we can also determine the moments as well. For this we have to use the element table, and we define the element table. How? We will simply we will be giving some label as well. I will simply start with the A, and then I will go to sequence number. And now if you wanted to find the moments, then you can use the 6 and 7, SIMC 7. So I will be going to the SIMC 6, and I will be going to the, I will simply leaving it with B as sequence number, and I will be going to the SIMC 7. So basically these 6, 7 are the components for the BEAM188 that tells us about the bending moments. So I will be simply closing this, and now I will be seeing that how I can see the bending moments. I will simply go to list results. Here in the list results, I have the option of element table data. I am selecting this and apply. So this is the values that we are obtaining at the different nodes, at the node 1, at the node 2. For the simple, if I apply this, so we are having the same values in the both direction. In the one is giving in the y direction, and the other one is giving in the x direction for each element. Okay, so I will simply select OK, and this was all about the analysis of a cantilevered beam. This is how we analyze a cantilevered beam in ANSYS APDL. I hope that you would have liked the video. If you have any concern, you can comment me below.